Hello everyone, this is Kalpana here. In this video we're going to see a problem from partial differential equations. So let's get going. Problem: form partial differential equation from f of x, y, z, comma x plus y plus z equal to 0 by eliminating f. We are given a relation and we are asked to form a partial differential equation by eliminating this f. Here f is a arbitrary function. Let's see. Given f of x, y, z, comma x plus y plus z equal to 0. Consider as equation number 1. Okay. Now let u equal to x, y, z and v equal to x plus y plus z. Now 1 takes the form f of u v equal to 0. Consider as equation number 2. Okay. The elimination of f from 2 gives determinant of dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y equal to 0. Now find dou u by dou x, dou u by dou y, dou v by dou x and dou v by dou y. Okay. Dou u by dou x equals to, right? Here we are partially differentiating with respect to x, so we'll treat y as constant. We can write this as y into dou by dou x of xz and apply u v whole prime formula, which is u dash v plus v dash u. See, if you are really good at derivative, just do directly. Partial derivative of x into z plus partial derivative of z into x. This gives us y into partial derivative of x with respect to x is 1 into z plus partial derivative of z with respect to x is dou z by dou x into x, which gives us y times z into 1 z. We have a notation dou z by dou x is p, so we'll get px, or we can write this as yz plus pxy. So we got dou u by dou x equal to yz plus pxy. Okay. Now we'll find dou u by dou y. Here we are partially differentiating with respect to y, so we'll treat x as constant. We can write this as x times dou by dou y of yz. Okay. Again apply uv whole prime formula. You'll get right. This gives us x times partial derivative of y with respect to y is 1 into z plus dou z by dou y into y, which gives us x times z into 1 z plus, we have a notation dou z by dou y is q, so we'll replace it by q. You'll get qy, which gives us xz plus qxy. We got dou u by dou y equal to xz plus qxy. Now let's find dou v by dou x and dou v by dou y. This gives us partial derivative of x with respect to x is 1 plus partial derivative of y with respect to x is 0 plus dou z by dou x. Since dou z by dou x equal to p, just replace it by notation. We'll get 1 plus p. Dou v by dou x equal to 1 plus p, and dou v by dou y will be partial derivative of x with respect to y is 0 plus partial derivative of y with respect to y is 1 plus dou z by dou y, which gives us 1 plus q. Dou v by dou y equal to 1 plus q, right? So we got yz, just substitute the values, we'll get dou v by dou x 1 plus p, dou v by dou y 1 plus q equal to 0, which gives us yz plus pxy into 1 plus q plus xz plus qxy into 1 plus p equal to 0, which gives us yz plus pxy plus yz into q, yzq plus pqxy plus xz plus qxy plus xz into p, xzp plus qxy into p, pqxy equal to 0, right? You'll get minus here, I'm so sorry. This term into this term minus of this term into this term, right? You'll get minus, 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 right? Where pqxy minus pqxy gets cancelled. Now write the terms that involves p and q in the LHS part and take the remaining terms which does not involve p and q in the RHS. So this gives us pxy plus yzq minus qxy minus xzp equal to minus xz becomes plus xz plus yz becomes minus yz, right? Which gives us, now take px common from these two terms, you'll get px times y minus z, and take qy common from these two terms, you'll get plus qy times z minus x equal to z times x minus y. We'll just take z common from these two terms. Or we can write this as p times y minus z into x plus q times z minus x into y equal to z times x minus y, which is the required partial differential equation. This completes the problem. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.